Hello everyone, my name is Peter Galiwango from MUK Science Turing Center. Our center is located at 100 Melmark Street in Lowell. If you want to make an appointment, please call me on 978-489-8380. So now let us get into our topic of today. Today we are still discussing alcohols, and today's objective, we are going to see how alcohols react to form what we call sulfonyl esters, and what do we do if we have a sulfonyl ester. So now, previously we showed you that in the previous videos that alcohols have a very strong nucleophile, the OH group, and this OH group cannot easily be displaced by substitutional nucleophilic reactions or by any other nucleophile. So we need to activate these alcohols for them to react. We need to add them to something. So previously we saw how we can react with the hydrogen halides and then the sulfonyl dihalides and the phosphorus trihalides. Today we are seeing how we can make a sulfonyl ester and how we can use the sulfonyl ester to form other new functional groups, as we shall see. All right, so now let us jump into the topic and discuss how sulfonyl esters are produced. So now a sulfonyl ester has a structure similar to this. Whereby X can be a halogen, chlorine, bromine, iodine, or fluorine, right? Then R prime can be any alkyl group. So now, when our alcohol reacts with a sulfonyl compound in presence of a pyridine, we form a sulfonated ester, which will look like so. Now this structure we shall form can easily be displaced by substitution nucleophilic reactions of any nucleophile that comes in. So that means we can form as many as functional groups as we want. So now, for example, if I have my alcohol as ethanol, CH3, CH2OH, reacting it with a sulfonyl ester, a very good sulfonyl ester we can use is a toluene sulfonyl chloride, which looks like this. So don't mind about the complexity of this structure. All we need is only a formation of a bond between the oxygen and the sulfur, that's all. So don't need to be overwhelmed by the big structures. So now in presence of a pyridine, so then we shall see, we are going to see how this leads to formation of the compound like this. So now this is going to be our final product for the reaction, and we shall see how we can use this product to synthesize other functional groups. So now let me show you how the mechanism of action occurs with this. So remember that our oxygen has a lone pair of electrons plus so what is going to happen is that the lone pairs of electrons from the oxygen will attack the sulfur, and this chlorine bond will break off, hence forming a chloride ion, and our resultant will be a CH3, CH2, OH to the sulfur into taurine. So now this is going to be our final structure, but remember oxygen has a positive charge here because it's having 3 bonds. So this is when our pyridine comes in as the base. So I'll use B for the base. Then it takes off the hydrogen and this bond goes back to the oxygen, hence forming the resultant structure above. So now we are going to see how can we use this structure above to synthesize other functional groups that we want. So using this compound CH3 CH2 O to the S O, so now using this structure, how can we make other functional groups? For example, this compound is a very good living group, so therefore any nucleophile we bring in can easily displace this off to include any functional group we want on these two carbons. For example, if I react this with a methoxyl group, what happens is that this nucleophile will attack this carbon and this bond breaks off. Hence, I will form CH3, CH2, O, CH3. I've formed an ether from substituting this complex structure with this nucleophile. What if I have a structure like this? Still the same mechanism. This nucleophile will attack the carbon, this bond breaks off, then I form CH3, CH2, C, triple bond CH, CH3. This carbon doesn't have a hydrogen. So now, you see how I have formed an alkyne, an internal alkyne from just substituting this into this structure. So therefore, that's how we can use these sulfonyl esters to form as many other functional groups as we can. So thank you very much for watching. Please tune in next time as we discuss further elimination reactions. Those who can make it up at our center, please, we are located at 100 Millmark Street in Lowell. Thank you very much and bye for now.